Alright, in this video we are going to learn about the quotient rule that could be used to help us with differentiation. Plus we're going to learn a few more trig derivatives in this video as well. But the quotient rule is a pretty cool rule that you do have to memorize and not mess up, but it's very, very helpful. Alright, so let's just get right down to it. The quotient rule will help you find the derivative of a function divided by another function. So if you have a function on top of another function and you want to find the derivative, here's all you got to do. You start off with the bottom, leave it alone, just rewrite the bottom function, multiply it by the derivative of the top function, minus, now you do the opposite. You leave the top function alone and you multiply it by the derivative of the bottom function. Now the order of the numerator is very, very specific, because if you get the order wrong, you'll get the problem wrong, because the order that you subtract does matter. And then you divide everything by the denominator squared. So in the denominator, there's no derivatives whatsoever. You just take your old denominator from the original problem and you find the square of it, or you just write it squared. Very, very simple. Now, if you prefer to use the u and the v, u for the top, v for the bottom, then the derivative is, again, the bottom, v, times the derivative of the top, minus the top times the derivative of the bottom, all divided by the denominator squared. Again, the du dx is just the derivative of u, the dv dx is the derivative of v, but if you prefer, again, to find the derivative of a function divided by a function, to find the derivative of u over v, you take the bottom times the derivative of the top, minus, now you take the top times the derivative of the bottom, all divided by the denominator, the bottom squared. Such a very, very, very simple rule, but I can't tell you how many kids flip-flop the top, they mess it up. So you just have to remember, and one way that I just remember is always start with the bottom. Start with the bottom, start with the bottom. So I start with the bottom, derivative of the top, minus top times the derivative of the bottom, and then divided by the bottom squared. Very, very simple. All right, the best thing I could do is just dive right into some problems. All right, now here is a problem that is set up as a numerator and denominator. Now, we actually already learned how to find this, right? We already taught you this one in other videos. The best thing you could do on this one is to rewrite it so that there is no denominator. Just bring the denominator to the top with the negative exponent. Then we're going to just straight up use the power rule, and we get negative 10 times x to the negative 6. And then remember, we don't like having denominators, or we don't like having negative exponents, at least. So we're going to move that to the denominator, where it could become a positive 6. Now that is a pretty easy way to get it. In fact, if I was ever to give you this problem, I would encourage you to solve it that way. But I just want to prove to you that the quotient rule can be applied here. Watch. All right. Start with the bottom. Multiply by the derivative of the top. Well, the top is a constant. The derivative of a constant is 0. Minus, now I'm going to take the top times the derivative of the bottom, all divided by the denominator squared. So again, let me walk you through that one more time. Bottom, left alone, times the derivative of the top, 0. Minus top times the derivative of the bottom, which is using the power rule, all divided by the denominator squared. Now check this out. First off, x to the 5th times 0, gone. That's 0. Then I get negative 10 x to the 4th, all divided by x to the 10th. X to the 5th squared, x to the 10th. Now using my exponent rules, you can subtract the exponents. 4 minus 10 is negative 6. But again, I don't like a negative 6, so I put it on the bottom as a positive 6. Or you could just think that all of the x's on top will cancel with 4 of the x's on the bottom, leaving 6 behind. So I get negative 10 over x to the 6th. Hey, same answer I got up here. So the quotient rule does work, but in this particular problem, it may be easier. All depends. Let's try another one here. All right. Now, once again, really, I could write this as 1 times x squared plus 3x, all divided by 6. So essentially, the 1/6 is just a constant out in front. That's all it is, right? So really, I could just use my constant multiplier rule, which just says, hey, to find, to find the derivative, just leave the constant there, just leave it there. Find the derivative, which is 2x plus 3, and then voila, you're done. Now, I could rewrite this as 2x plus 3 all divided by 6, eventually reverse engineering what I did in the beginning, right? When you got that 1 up there, you just got 2x plus 3. Remember what I've said in classes, to the side or on top is the same thing. So again, that's how you get that answer. But what I want to show you is that I could use our new quotient rule to get this answer as well. So again, I'm going to take the bottom, leave it alone, times the derivative of the top, minus, now I'm going to take the top, times the derivative of the bottom, 0, the derivative of the constant, 0, all divided by the denominator squared. All right, so on top, 0 times this, all gone, wipes it all out, and I just get 6 times 2x plus 3, all divided by 36. Now, I know that I could distribute that 2, or I could distribute the 6, excuse me, but I'm not going to because that 6 could reduce the 36 in the denominator to a 6, and I get a final answer of 2x plus 3, all divided by 6. Voila! The exact same answer I got earlier. So the quotient rule is a very, very useful rule anytime you have a numerator and a denominator. But watch out, sometimes you could still use other rules that we've already learned. But sometimes, whoops, sorry, went the wrong way. Sometimes we encounter problems like this. And unfortunately, here I have x's on top, and I got x's on the bottom. I got a binomial on top, I got a binomial on the bottom. There's no way that I can rewrite this to use the power rule. It's impossible. So in a problem like this, the only way to find the derivative is with our new friend, the quotient rule. All right, leave the bottom alone. Times the derivative of the top, 5, minus the top, times the derivative of the bottom, 2x, all divided by the denominator completely squared. All right, now I just got to do my cleanup work. I talked about that in other videos. Oftentimes using the rule is very, very simple. It's all the cleanup work that comes after that can be a bit tricky. All right, now I just got to do some algebra here. Let me distribute. 5x squared plus 5. Now be careful, I got to distribute the negative and the 2x. So I'm going to get negative 10x squared. And I'm going to get a positive 2x. Okay, just hopefully you follow that. Pretty easy. All divided by, now I'm going to tell you, I always tell kids, don't square the bottom out. Just leave it. Just leave it like that. It's actually easier to use, right? What do I want to do with a derivative? Find the slope at a given point. So I'd rather there be less x's. So just leave the bottom the way it is. And all I got to do now is on top is clean up some like terms. So I got a negative 5x squared, because I had 5x squared, negative 10x squared is negative 5x squared. And then I have a 2x. And then I got a positive 5. All divided by x squared plus 1 squared. Again, seriously, don't square the bottom out. Just leave it like that. It actually makes it easier. All right, guys, there's my derivative. Pretty harmless. And a great way to use the rule. It's a very simple rule. You just got to use it, right? All right, now here's another problem that at first glance, I have a numerator, I have a denominator, so I'm already thinking quotient rule. But boy, this is going to be hard to do because this numerator looks very ugly. So I want to kind of just teach you real quick that sometimes you have to clean a function up. Sometimes you have to rewrite a function first before you find the derivative. And what I'm going to do here is actually quite simple. I'm going to take the top and the bottom, and I'm going to multiply both of them by x. Now, where did I get this x from? Well, that was my denominator right here. And I hate, H-A-T-E, hate double fractions. So multiplying by that denominator of x is going to help get rid of this. Because now when I distribute that x on top, I get 3x minus 1. Hey, no more double fraction. And when I distribute the x on the bottom, I get x squared plus 5x. All right, so it's the exact same function. Sorry, I don't like how that 5 looks. It's the exact same function, just looks different. But now it's going to be 100 times easier to find the derivative. All right, using the quotient rule, leave the bottom alone. Multiply by the derivative of the top, which is just 3, minus, leave the top alone, multiply by the derivative of the bottom, 2x plus 5, all divided by the denominator, x squared plus 5x, all squared. Again, I would never do anything with that denominator. Just leave it squared. All right, on top, I got to do some fancy distribution here. 3x squared plus 15x. All right, back here, I'm going to FOIL and distribute the negative. So I got a 6x squared, but it's negative. I got a 15x, but it's negative. I got a negative 2x, but it's now positive. And then I have a negative 5, but now it's a positive 5. And I get a lot of kids, another big mistake, a lot of kids can just forget the denominator. They just get so caught up in the numerator, they totally forget the denominator. All right, now I'm just going to combine my like terms. 3x squared minus 6x squared is negative 3x squared. A positive 15 and negative 15 add up to 0, so I have a 2x and a 5. All divided by, and again, don't multiply the bottom out. It's actually more convenient if you just leave it alone. All right, guys, there's your final derivative. So again, this is a good problem where sometimes you got to do a little bit of dirty work in the beginning to make it easier to differentiate, and then just use the rule. Nice and simple. All right, now what I want to introduce you to is this is actually kind of separate. This actually has nothing to do with the quotient rule. Hopefully, I've shown you how easy the quotient rule is in just a couple problems. Please write down that quotient rule. My goodness, you got to study that. All right, but now we're going to dive into a couple more trig rules. Now, we have already learned that the derivative of sine, hopefully you're saying it out loud right now, cosine of x. And we've learned that the derivative of cosine of x is negative sine of x. Well, now we just have a couple more. Now, again, you just got to memorize these. Memorize them. In my classroom, I'll put a poster, but you got to memorize them. All right, the derivative of tangent is secant squared. Check, check. The derivative of cotangent is negative cosecant squared. Easy enough. The derivative of secant is a little weird. It's secant times tangent. So not only do you keep the secant, but then you multiply by tangent. And the derivative of cosecant is negative cosecant x times cotangent x. So again, I don't have anything other to tell you than just to memorize those. Sorry. All right, let's put them to use now. So here is a trig problem, but I'm going to need the quotient rule. Here we go. To find the derivative, I'm going to write the top all by itself. Oh, whoa, oh my gosh. Sorry. Wrote it right, said it wrong. Leave the bottom by itself. Multiply by the derivative of the top. All right, what's the derivative of the top? Well, the derivative of 1 is 0. The derivative of cosine is negative sine. So a negative with a negative sign, because there's already a negative there, is going to make a positive sine of x. Minus, now I'm going to leave the top alone. I'm going to multiply by the derivative of the bottom, which is cosine of x. Divided by the denominator squared. All right, let's see here. On top, sine times sine is sine squared of x. Let me do a little bit of distribution here. That's going to be 1 times cosine is cosine, but don't forget the negative. Negative cosine times cosine is negative cosine squared, but because of this negative, it's now going to become positive cosine squared. And remember, instead of saying sine quantity squared, I can write sine squared, put it right there. Now, what's going to happen here? Check this out. You're going to love this. All right, remember one of our old trig rules, trig identities. Sine squared plus cosine squared is just 1. So I get 1 minus cosine of x on top, all divided by sine squared on the bottom. There is my derivative, which, interesting enough, looks very, very similar to the original function, but it is different. So pretty nice problem there. All right, guys, one more derivative problem to go here. And actually, I won't need the quotient rule at all for this one. I'm just going to need the power rule and my new trig rules. All right, to find the derivative. Now, this is the addition rule. Remember, the addition rule is not fancy at all. It's just find the derivative of the first, find the derivative of the second, and you're done. So first thing I'm going to do is I am going to rewrite that as x to the 1/3. Now I could use the power rule. 1/3 x to the negative 2/3 plus. Now, 7 is just a constant, so I'm going to leave it there. Now I'm going to go back to my rules here real quick. The derivative of cosecant is negative cosecant times cotangent. All right, so the negative 7 just stayed there. I'm going to multiply that by negative cosecant x times cotangent x. All right, now I just got to clean this all up. All right, first off, I don't like negative exponents, so I'm going to move that to the bottom as x to the positive 2/3. And then 7 times the negative is going to make a minus 7 cosecant x cotangent x. And that's about as clean as I could get this. So not too bad, kind of an ugly answer, but it is at least the derivative. All right, guys, quotient rule. Pretty simple rule. It could always be used anytime you have a numerator and a denominator. But like I showed you in the first couple problems, sometimes it's actually easier to just kind of rewrite it, and that way you can use a power rule. But there's lots of problems that you cannot rewrite as a power, and that's where you have to use the quotient rule. But it's a really easy rule. Just memorize it and move on. All right, guys, love it. See you in the next video. Hopefully this quotient rule makes sense.